Let's finalize. Please, if you're in a noisy place, mute your mic. So the next bit is the method of integration by partial fraction decomposition. So the method of partial fractions is applicable only to rational functions. And if you remember from your calculus 1, a rational function is simply a function which can be expressed as a quotient of two polynomials. So this method is only applicable for rational functions. So a rational function is a function of the form f of x equals to p over q, where both p and q are polynomial functions or simply polynomials. So the idea is to re-express a function of the form p over q when both p and q are polynomials in such a way that we have sum of fractional functions whose integral is easier to evaluate using previously discussed methods for the method of use substitution. So for example, when we have a fraction 1 over x squared minus 1, then all of us know that x squared minus 1 is a difference of two squares, which can be written as x minus 1 times another x minus 1. So what we are going to discuss in this section is to see how we can transform function, for example, 1 over x squared minus 1 into this form as a half x minus 1, then plus minus a half over x plus 1. So if we are able to split a rational function into two parts, like for example, this case, then we can easily integrate the function 1 over x squared minus 1.
You're not casting your screen.
Come again? Are you able to see my screen?
Yes,
What I'm projecting?
Yeah, but not clearly.
Take your projection nearer. You know, it's very far.
Zoom your screen.
So are you able to see the slide I'm presenting, the partial method of partial fraction?
Yes.
Yes.
Zoom.
Okay, good.
Zoom.
Yeah. So if you have been asked to integrate 1 over x squared minus 1, so it'll be as good as integrating these two parts of the fractions, a half x minus 1, and then plus minus a half x plus 1. But so the greatest question to ask ourselves is, how do we transform such a function 1 over x squared minus 1 as sum of these two parts of fractions, where the denominator of each of the two parts is a linear function. So to do that, we discuss different types of rational functions, and the type of rational function is what will dictate whether we can do the partial fraction decomposition, and after doing partial fraction decomposition, get the integral of the fractions obtained from the original rational function. So a function is said, a rational function is said to be proper if the degree of the numerator is strictly less than the degree of the denominator. So if I have two polynomials P and Q, then the fraction P over Q is proper if the degree of P is strictly less than the degree of Q. And degree of a polynomial is simply the highest power in the polynomial. So for example, x squared minus 3x plus 7 is a polynomial of degree 2. The highest power of x is 2. And then the function x squared minus 16, x power 4 minus 16 is of degree 4 because the highest power of x in this function is 4. So if you have a function of degree 2, a polynomial of degree 2 over a polynomial of degree 4, this is an example for a proper rational function because the degree of the numerator function is strictly less than the degree of the denominator function. Then these are the two fractions, 2x squared plus 7 is of which degree? 2x squared plus 7 alone. From your SMA 103. 2. So the highest power of x is 2. So that's that numerator is of degree 2. And then denominator, x minus 5 is a polynomial of which degree? 1. 1, because the highest power of x is 1. So if the numerator is of degree 2 and the denominator is of degree 1, then it goes against the definition of proper rational function. So 2x squared plus 7 over x minus 5 is an example of an improper rational function because the degree of the numerator is greater than the degree of the denominator. Then this last fraction, x minus 2, is of degree 1. X minus 5 is of degree
1.
degree 1 again. So cases whereby the degree of the numerator is exactly the same as the degree of the denominator is also an example of an improper rational function. A rational function is only proper if the degree of the numerator is strictly less than the degree of the denominator. It's a strict inequality. So the first thing, when you have been asked to solve a problem involving partial fractions decomposition, is to ensure that your numerator polynomial has degree strictly less than degree of the denominator polynomial. That is to mean that the function you are dealing with should be in such a way that the fraction itself or the rational function itself is proper. So once we have determined that P over Q is proper, which is another way of saying the degree of P is strictly less than the degree of Q, then we consider several cases. And what determines on how the partial fractions will be decomposed is the structure of the denominator. After ensuring that the fraction is proper, then the structure of the denominator is what is going to guide you on what to do on how to decompose P over Q as a sum of fractions, what we call the partial fractions. So the first case is when you have determined that P over Q is proper and Q is a product of linear functions. So if Q is of the form x minus a1 times x minus a2 all the way times x minus an. And please note that a1, a2, an are real constants. And we can as well have x plus a1, x plus a2, or x plus an. There's no problem. It can still be plus or minus sign. There's no mistake in that. Also, we can have constants before this x variable. We can have maybe b1x. We can have here b2x. We can have bnx, then plus an. There's no problem, provided that the denominator involves a product of linear terms or linear functions in x. So if that's the case, then your partial fraction decomposition P over Q will be of the form a constant, say A1, over the first linear term, x minus A1, plus another constant A2 over x minus A2, plus all the way up to another constant, say an, over x minus A2. Where this capital A1, capital A2, capital A3, all the way up to capital AN are constants which you are required to find. A1 capital, A2 capital, up to AN capital, you need to find them. So the question will be, how do you determine A1, A2, all the way up to AN? So, for example, in this first rational function, we have 5x squared plus x minus 28 divided by x plus 1, then x minus 2, then x minus 3. I want you to tell me what is the degree of the numerator in this rational function. What is the degree in the numerator in this case?
2.
Degree is 2. Numerator degree is 2, correct? And then denominator, what is the degree?
1.
Remember, to get the degree of the denominator is as good as now when you multiply all those terms, what will be the highest power of x? That's what determines the degree. After multiplying through all those brackets, the highest power of x will be 3. Okay? So when you multiply all those linear factors, you are sure that the highest power of x will be 3. So which means the degree of the denominator is? Degree of the denominator will be?
3.
3. Correct.
3.
So then now, because the degree of the numerator is 2 and the degree of the denominator is 3, then the fraction 5x squared plus x minus 28 over x plus 1 times x minus 2 times x minus 3 is a rational, is a proper fraction. So which means then you can apply this definition of partial fraction decomposition. So you will write, so please, I want you to take your pen and pencil. So I want to see how these values obtain here. So we'll write A1 over the first linear term is x plus 1, then plus A2 over which fraction? Over which value?
X minus 2.
X minus 2, correct? X minus 2, then plus A3 over
X minus 3.
x minus 3.
X minus
Okay?
3.
Yeah.
Yeah.
So please write that A1 over x plus 1 plus A2 over x minus 2 plus A3 over x minus 3. Once you are done, you let me know.
We are done.
Good. So then now, you write on the left-hand side of that one, you have 5x squared plus x minus 28 divided by x plus 1 times x minus 2, then x minus 3. So equate what you have as your a1 over x plus 1 plus a2 over x minus 2 plus a3 over x minus 3 to what we have been given, the fraction which we have been given. Please participate.
Yes, we are there.
Good. So then the three fractions which we wrote a1 over x plus 1 plus a2 over x minus 2 plus a3 over x minus 3, I want us to write it as one fraction. And what would be the LCM of those three fractions?
X plus 1, x minus
X
2,
plus
x
1.
minus 3.
Correct. X minus 2, x minus 3. So how many times does x plus 1 go into that LCM?
X minus 2, x minus 3.
Correct. So then you write a1 into x minus 2 into x minus 3. Just like now, when you are adding fractions, the primary work. So we want to put all those three fractions as one fraction. Then plus, how many times does x minus 2 divide the LCM?
X plus 1, x minus
X plus 1, x minus 3. So you'll write a2 into x plus 1 into x minus 3. Good. Then lastly, how many times does x minus 3 divide the LCM?
x plus 1,
X plus
x
1,
minus 2.
x minus 2.
Correct. X, so you'll have a3 into x plus 1 into x minus 2. So remember that thing is still the same as 5x squared plus x, then minus 28 divided by x plus 1, x minus 2, x minus 3. Are we there?
Yes.
Good. So what if we say that those two fractions are the same? What does it mean? From the structure of the fractions we have equal sign. What is the implication of that equal sign?
That 5x squared is equal to a1 x minus 2 x minus 3.
Okay, just in simple terms, or if you are to explain in terms of a numerator and denominator, what does this equal sign mean?
They are the same.
Yeah, they are the same. What are the same? Or what are equal?
The two fractions.
The individual components.
The two fractions are equal. That's what I want you to tell me. Is the two fractions are equal. What does it imply? The structure of those fractions.
The individual components of the numerator are equal to the other one.
Yes, the numerators are the same because we see that all the denominators are the same. Are you able to see that?
Yes.
That what we have in the numerator on both sides of the equation should be the same because the structure of the denominator on both sides you have the same fraction, the same value. X plus 1, x minus 2, x minus 3 is a denominator on both sides of the equation. Are you seeing that?
Yes.
Yes.
Yeah. So which means then you'll say 5x squared plus x minus 28 should be the same as a1 into x minus 2 times x minus 3 plus a2 into x plus 1 into x minus 3 plus a3 into x plus 1 times x minus 2. We are just equating now the numerator on both sides because the denominators are the same and we have equal sign.
Yes.
Good. So once you have equated the two numerators, is the time now to find the constants a1, a2, and a3. And there are many ways of doing this. One way, you can expand the side which have the constants a1, a2, and a3, then rewrite those terms such that we have those coefficient of x squared, coefficient of x, and then the constant term, and then relate the coefficients on either side. Those the coefficient of x squared on the left-hand side is related to the coefficient of x squared on the right-hand side. Similarly, coefficient of x on the left-hand side to be related to coefficient of x on the right-hand side. And then the constant term on the left-hand side to be related to the constant term on the right-hand side. Then you'll have a system of linear equations in terms of a1, a2, and a3, and you solve them. But I know some you have not yet done linear algebra, and sometimes you may find a system of linear equations which may be which involve this, like for this case, 3 unknowns, which you don't know how to solve. So the easiest way to deal with such cases it will be to get each constant a1, a2, a3 one at a time. And this is how we do it. Like if you observe your, I don't know if it's your left-hand side or right-hand side, the time, the side which has the constants a1, a2, and a3, which value of x should I fix in that equation to guarantee the place of a2 and a3 to be 0? And remember, for the part with a2 and a3 to be 0, it simply means one of the brackets should be giving you a 0 value. So that 0 times anything gives you 0. So like we should fix x for which value to get the term which has an a2 and an a3 to be 0.
-1.
-1, correct. So you say let x to be -1. So when you pick x for -1, you'll be assured that the place where we have a2 will give you 0 because -1 plus 1 is 0. So 0 times anything will give you 0. And then -1 plus 1 is 0, then times x minus 2 times a3 will still give us 0. So when you let x to be -1, the part which has an a2 and the part which has an a3 will all of them go to 0. Okay?
Yes. Yes.
So then now, when you fix x to be -1, what is the value on the left-hand side? So 5 times -1 squared plus -1 minus 28 will give you?
-5 squared.
Negative?
24.
Negative 20? Oh, 24, correct. Then where there's x on the other side involving the a1, a2, a3, replace x for -1. We'll have a1 into -1 minus 2 times -1 minus 3. So can you work out and tell me the coefficient of a1?
Excuse me.
Yes.
Can we go back to where we found that x is equals to -1, where we substituted x is equals to -1? I didn't get what you said.
So where we fix x to be -1 to do away with the terms having a2 and a3, because the terms which have a2 and a3, they have a bracket x plus 1.
Okay, yeah.
Yeah, so this now, when you fix x for -1, those two parts will not be in the equation, because all of them will simplify to 0.
Yeah.
So then now that value of x of -1 is why we are now substituting every side of the equation. So where does x put -1?
Okay. Yes, I get you.
So what would be the coefficient of a1?
-2.
Negative?
2.
How are you getting -2?
12. 12.
It will be -12 because we'll have -1 minus 2 times -1 minus 3, okay?
Yes.
-1 minus 2 will give you -3, then -1 minus 3 will give you -4. So -3 times -4 gives you 12, okay?
Yeah.
Yes.
Yeah.
Yeah, sure.
So we'll have 12a1 equals to
24.
24. So what's the value of a1?
2.
Negative 2. Because remember, we had you divide through by 12. So -24 by 12 is the same as -2. So this is where this -2 is coming from.
Please pardon me.
Yes.
So that's where they are getting this -2. Okay.
Do this physical.
Yes.
Then to get a2, you need to find a way of eliminating part which has a1 and part which has a3. Which value of x should you fix to do away with parts having a1 and parts having a3?
2.
When you fix x for 2, then you will be sure that the term which has an a1 will cancel out because we have a bracket x minus 2. So 2 minus 2 is 0, okay?
Yeah.
And then the term which has an a3 also has a bracket x minus 2. So 2 minus 2 is also going to give you 0. So can you replace x for 2 and tell me the left-hand side of the equation will give you?
-6.
-6. You get
Yes.
-6, okay? Yeah.
Yes.
Then what will be the coefficient of a2? Where would this x put 2?
-3.
Because we will have 2 plus 1
3.
times 2 minus 3. We get -3, okay?
Yes.
Yeah, so we'll have -6 equals to -3a2. So what's the value of a2? A2 will be
2.
A2 will be
2.
positive 2. Yeah, so this explains where we get where this 2 was obtained from. Then the last part is to get the value of a3. So how do you eliminate part with a1 and a2 simultaneously to remain with only part with m3? Which value of x do you fix?
3.
3.
So when you fix x for 3, we are assured of doing away with part with a1 and part with a2 because both the two parts have an x minus 3. So 3 minus 3 is 0. So can you fix 3 for x and tell me the value on the left-hand side?
Endo chote.
20.
20, correct. So when you replace x for 3, you get 20. So the left-hand side will be 20. Now, can you replace 3 for x, the part which has an A3 to tell me the coefficient of A3?
Hello.
Oh.
Will be?
4.
4, correct. We'll have 4 A3. So when you solve for A3,
5.
5.
we get 5. So therefore, that's how this 5 was obtained. So if the question was now to integrate 5x squared plus x minus 28 over x plus 3, x plus 1 times x minus 2 times x minus 3, then it will be the same thing as integrating each of these fractions. And you can see they are very standard integrals to evaluate because it will be simply using the U substitution. I think that.
Yes.
Yeah. So what will be the integral of minus 2 over x plus 1 dx? So what is the integral of minus 2 over x plus 1 dx? Because now you'll be supplying the integral to each of these 3 terms. Which method will you apply?
Substitute.
U substitution, correct. So you fix U to be x plus
1.
x plus 1, correct. So therefore U equals to x plus 1, which means that the U will be 1.
1.
Du will be 1 times dx. So just du the same as dx, okay?
Yes.
Yeah. So which means now, can you finish and tell me the final value of the integral of minus 2 over x plus 1? What will be the final value for that integral for that part alone? Minus? What do you minus? Plus. Minus? The final answer for the integral of minus 2 over x plus 1, after you do the U substitution and you do everything?
Minus 2 ln x plus.
Correct. Minus 2 ln of x plus 1, okay? Are you getting that? That the answer for the first part will be minus 2 ln of x plus 1.
Yeah.
Yeah. And then the second part, what will be the value of the integral of 2 over x minus 2? Apply the same process.
2 ln x.
Correct. 2 ln of x minus 2. And then the last part, integral of f5 over x minus 3.
ln of x.
Minus
Okay.
ln
5
minus 3.
ln of x minus
X
3.
minus
Correct.
3.
Yeah, then you add the constant of integration. Then you'll be home. So these are the examples here. Now, when you have been given, so what is our p of x in this next integral example 1 here? What is the degree of the numerator? Remember when we say dx over x squared minus 7x plus 10 is the same as having 1 over x squared minus 7x plus 10 dx. So which means p of x is 1. So what the degree of the polynomial p of x equals to 1? Degree will be degree of the numerator? Degree of the numerator in this example 1 here.
0.
0. Yeah, because there's no x. So this is the same as 1 times x power 0, okay? And then degree of the denominator?
2.
2. So that is the fraction proper.
Yes.
Yeah, it's proper
Yes.
because the degree of the numerator is strictly less than degree of the denominator. So in such case now, you see this a quadratic expression or quadratic function, but you can clearly see that you can factorize this quadratic as a product of two linear terms. So x squared minus 7x plus 10 is the same as x minus 2 times x minus 5. So which means then your given integrand can be written as these two partial fractions, a over x minus 2, then plus b over x minus 5. So I want us to use the same method to find the values of a and b. I want us to find the values of a and b the same way we have found a, b, and c in the previous example. So once you have determined that the fraction is proper, and then the denominator can be written as a product of linear terms, then you write the correct structure of your partial fractions. The next step will be put these two fractions as one. Put these two fractions as one fraction. What would be the LCM of those two fractions?
X minus 2, X minus 5.
Correct. X minus 2, X minus 5. So you write, the right hand side will have X minus 2, X minus 5 as our denominator. Then ask yourself, how many times does X minus 2 divide the LCM?
X minus 5.
Times? X minus 5. So we'll have
X minus
A
5.
into X minus 5 plus. How many times does X minus 5 divide the LCM?
X minus 2.
X minus 2. So we'll have B into X minus 2. So which means then you'll have 1 over X minus 2 times X minus 5 is equals to A into X minus 5 plus B over X minus 2 divided by X minus 2, X minus 5. Are we there?
Yes.
What's the implication of that equality? What does that equality mean?
The denominator equals the denominator.
So yes, denominators are just the same, so we can as well ignore. So we simply equate the numerators, okay?
Yes.
So we'll have 1 equals to A into X minus 5 plus B into X minus 2. Okay?
Yes.
Yes.
Yeah. So the next work will be to find A and B.
Yeah.
And for us to find A, we need to find a way of not having the term which has a B to be 0. And for us to get B, we need to find a value of X which will make the term having A to be 0.
5.
So what would be the best choice of X to guarantee us having a 0 value in the B place?
5.
5. Remember, when you say x equals to 5, we don't have A. I want us to start with solving for A. So that the term which has A is not 0, but term which has B should be 0.
2.
So when you fix x to be 2, we are sure that B will not be in the equation, okay? Yeah, so say let x to be 2. So left hand side will be? When x is 2, left hand side will be? When you replace x for 2, what will be the value on the left hand side?
1. Remains 1.
Yes, constant remains to be constant, okay?
Yes.
So 1 equals 2. So put 2 where there's A. Where there's x in the right hand side. Negative 3.
Negative 3A.
So we'll have, yes, 1 equals negative 3A, which means A is negative a third, correct. So A is negative a third. Now, can you tell me which value of x we need to fix so that the term which has A goes to 0?
5.
5. So you say let x to be 5. Left hand side will be
1.
1 because constant does not change. Right hand side
3.
3B.
3. So we'll have 3b. So what is the value of b? B will be a third. So therefore now you can write your fractions. So this is what you have. So these are the same answers that they obtain here. So A is negative a third, B is a third. So which means the given integrand can be written in this form. So which means then the integration on the left hand side is the same as integrating each part on the right hand side. So this integral is the same as the integral of the first fraction plus the integral of the second fraction. And I hope this answer is not magic, as you can see from your previous experience. I hope this answer makes sense to you.
Yes.
Yes,
Yeah.
it's good.
Yeah. So I will want you to extend the same thing now. Check when the fraction is proper and the denominator is having a quadratic expression which cannot be factored as a linear term. I want you to check out how we do the partial fraction decomposition. And then lastly, the other case is when we have a product of linear terms, but then some of the linear terms are repeated. Check out on that to see how we do the partial fraction decomposition. Hiyo ni yako Aisha. Ile. Or you want to go to 14, lakini nipatie 14. Hata mateka yako huko. Sawa sawa. Oh, sawa. Na mateka yako hapo. Hiyo kabisa. But I'm finishing. So that's what you do. So check out the other cases. So there's quadratic aspect and then there's a case of repeated linear term. But from what I've explained, then we should be able to follow through and see what happens. Also, another case is when the fraction is not proper. You will have first supposed to do the long division to get a proper fraction, then the rest of the steps follows. So the link I shared can as well help you to do the connection, and I'll also share the remaining part of the handout. I need to stop at that point. Now, next week, we will have the elections on Wednesday.
Yeah.
Do you have any activity next week?
Yeah, we are having the election.
Yes, next week we'll be having elections.
Also, then it means that it will be very unfair to put people in exam room.
Yeah, that's
Very
me.
unfair.
Yeah. So so we can say maybe next week
is not
you vote
suitable.
your preferred student leaders, and then we do the card the other week.
Yes, that's fair.
Yeah,
I
next
think
week
that
part
will be
one. Next week
fair
part.
enough also to help you to connect the dots from what we've done. Okay.
Yes.
Yeah.
Yeah. So
Yes.
next week you can do the voting and also prepare for the card the other week, not next week.
Okay.
Okay. So have a good day.
And so I also had an inquiry.
Yes.
So on the SOMAS, based on the way you said you're going,
Yes.
are we going to be doing formulas in the system, or are we going to be doing it in terms of are we going to be given faces, or are we going to be writing the formulas and working out the
Well, it will be both. So I know sometimes typing math equations can be messy. Questions which I expect to do that one, I'll give the options. Then those which require workings will just be working.
okay.
Typing equations,
okay.
I'll not put questions for you to type equations because it can be messy.
Yeah, because there's some symbols basically in the keyboard.
Yeah.
They are so hard to find.
Yeah, I know that. So if
Yeah,
it is such kind, I am not required to type the math symbols. I put them as options. But the questions which are required just to working out will just be writing and then you'll scan.
Yeah, that's in order, sir.
Okay.
So we'll just
That's
do it
fair.
physically instead of
Okay.
online.
Wazi kati imetolewa.
Instead of doing the cut online, why don't we do it on paper?
Yes, we do it physically.